Hello, welcome back to our channel. And on your screen, we see a problem statement. We are given a differential amplifier with an active current mirror load. So as you can see, this is a differential pair. And on top of that, you have this an active load. Okay, so let me write here, it is an active load. And this is your differential pair. And this is a tail current source ISS, and we have got the supply voltage VDD. Now the question is, this is a closed loop amplifier. Why it is called closed loop? Because the output is a single-ended, which is taken from this node, and the output is being fed back to one of the input. Here is the gate pin of the transistor. Okay, so that's why that forms the closed loop. In case you don't have this connection, it is an open loop amplifier. So for now, for this closed loop amplifier circuit, the magnitude of the open loop, low frequency, small signal voltage gain is VO over V in, okay? Or let me write it here. The voltage gain, open loop or closed loop, would be expressed as VO over VID, take a magnitude of it, okay? And this is said to be 40. So VID is basically the difference between the two inputs, that is V1 here and the V2 here. In case of the closed loop, V2 is now your output voltage being fed to V2, okay? So all the transistors, second assumption here is that all transistors are biased in the saturation region. So these transistors are biased in the saturation region. Okay. And we have said that the current source is ideal. So it is a constant current source irrespective of the voltage across it. And we don't consider the body effect, neglect the body effect. It means the MOSFET has the fourth terminal, that is the body, which is tied to the source in case of NMOS, and which is tied to the VDD in case of a PMOS. So we don't consider that into the circuit. Now there is also channel length modulation that is asked to be to forget. Okay, so channel length modulation is also not considered, which is a lambda. So channel length modulation is basically we have seen in our previous module. So it is essentially you have this output characteristics of a transistor, and you ideally have such kind of curve where this is your IDS and this is your VDS for a given value of VGS. However, so this is the case when lambda is equal to 0. However, in practical devices, your current ID is not constant with respect to VDS, rather it is increasing with respect to VDS. So the slope of this is your transconductance, okay, and that gives you channel length modulation, because your channel length, the current of the MOSFET is increasing with the increase of the VDS, okay. So we are neglecting the body effect, we are neglecting the channel length modulation, and we are also neglecting the intrinsic device capacitances. So in the MOSFET, you have the capacitances such as the capacitance between gate and drain, between gate and the source, all these, and between drain and the source. You have to neglect all those capacitance. And the question is, you have to calculate the closed loop low frequency small signal voltage gain, which is again V out over V in. Okay, so this is VID, or you can also say V in the case V out is equal to 0. Okay, and you have to calculate. So to summarize, the question is, you are given the closed loop open loop gain to be 40. Okay, the magnitude is 40, and you are asked to calculate closed loop gain. So that's the question here. So how to approach this problem? So in the block diagram form, This circuit diagram is represented by this block diagram where you have got the input, and input here is your mixer. So the mixer job of the mixer is to add or take a difference of the two signals at its input. So if it takes the difference between the two signals, that is input and the output being fed back to input, this system is called as negative feedback system. If the job of the mixer is to add two signals, that is the input and the output is also being in phase with the input, that is here is the plus sign, then that is a positive feedback system. So currently we are talking about amplifier with the negative feedback system right here, because the output being fed through the feedback network beta. So you have some passives here, whether resistors, capacitors, inductors, or combinations of thereof, where the job of this feedback network is to attenuate the output signal. It takes a fraction of the output signal. It means it reduces the output signal and feeds the portion of it to the to be added with the or subtracted in this case to be with the input. Okay. And this is your AOL, which is the open loop gain, which is set to be a 40 in our case. So you got the input, you got the amplifier with the open loop gain, you got the feedback here. So now your output is directly fed back to the input without, it doesn't have any passives in between. So you have a direct connection of output to the input. So that's why feedback network beta is equal to 1 here. So let me write here the feedback beta is equal to 1. Now you can write the transfer function of this system, that is the output divided by the input, okay, which is given as the open loop gain divided by 1 plus beta times open loop gain. So this is the classic example when you have negative feedback system. So this is the case when you have negative feedback system. In another case, you can write output divided by input is equal to AOL divided by 1 minus beta times AON. This is the case when you have positive feedback system. So this is generally the system when your amplifier becomes an oscillator, which you don't want. So when, or you purposely design an oscillator, so your closed loop transfer function should take this form. In other case, in the present case, your closed loop transfer function should take this form, which is the case here. So plus sign for the negative feedback and the minus sign for the positive feedback. So now let us focus on this transfer function. So value of AOL is given to be 40, and beta, value of beta, we have seen that there is a direct connection of output being given back to input, that is the 1. Here is the beta is equal to 1 right here, multiplied by 40. So that is approximately or equal to 40 divided by 41. So it comes out to be approximately 0.97 or something like that. Okay. So that's the answer. So your closed loop low frequency small signal voltage gain would be about 0.97 and something like that. Okay, rounded off to 3 decimal places. All right, so we